Friends, our today's topic is relation and function, and as we all know that relation and function, this is the topic which is the extended part of relation and function that we have studied in class 11th. Okay, so what we have studied in class 11th about relation, in class 11th about relation we have done that if A is a set and B is another set, and we have to find the relation between set A and set B denoted by ARB. It is nothing but the subsets of A cross B. A cross B we have studied, it is Cartesian product between sets A and B, and ARB represents the relation between two sets A and B. So this we have studied in class 11. Now in class 12 we have to study about its types. Relations के type कौन कौन से हैं? So now we are going to discuss that part. Let us see. Now, types of relation. Suppose a relation R or ARB ARB means subsets of A cross B. It is given, and obviously it would be in terms of its elements as pairs. Because we have just shown that ARB is subsets of A cross B. A cross B indicates that all elements should be in paired form, and subsets of A cross B is relation. So relation is a set that will comprise all its elements in paired form. Now types of relation, the number one is reflexive. It is a 6 mark question that always occur in CBSE board exam. Reflexive relation. For reflexive relation, if A comma A belongs to R or all A belongs to R, this is the condition to be reflexive relation. A comma A means element should repeat, element like 1 1 2 2 3 3. If the pair like this is in R, we will call it the relation R follows reflexivity, or relation R follows the property of being reflexive. Now second one is symmetric relation. What symmetric relation says? It says if A comma B belongs to R, and this implies B comma A also belongs to R, then we say that then R is symmetric relation. And remember, for all A and B both must belongs to R. So this is the if condition. A comma B means both the numbers should be different. Remember this. And its reverse, B comma A must also belongs to R. If there is so, then it is symmetric also. Now there is third one. It is transitive relation. What transitive relation says? It says if A comma B and B comma C belong to R, and if this expression implies A comma C belongs to R, okay, then we say that R follows transitive law. While we are verifying this relation, we must say A comma B and B comma C means last element of first pair and first element of second pair, these two should be same. This and this must be differ. And then these two pair with these two must belong to there. If it is so there in R, then we say that R is transitive relation. And remember, note, if relation R follows all three relations, if all three are true, all three relations, then we say that R is an equivalence relation. R is an equivalence relation. So I am just recalling once again. First one is symmetric relation, reflexive relation, sorry, reflexive. A comma A must belongs to R is the condition. Symmetric, if A comma B belongs to R and implies B comma A belongs to R. And transitive, if A comma B and B comma C belongs to R, implies A comma C belongs to R. If it is so, then R is called as equivalence relation. Now there is one special thing in this. There is one special concept. See, what is that? It is about symmetric and transitive. For symmetric law, symmetric relation, what is that? If A comma B does not belongs to R, it's a special case. Obviously, B comma A will also not be in R. In that case, remember, in that case implies R is symmetric. इस केस में R सिमेट्रिक रिलेशन होगा. Similarly for transitive, it says in the same manner, if A comma B and B comma C both does not belongs to R, implies A comma C does not belongs to R. It means R will be transitive. R will be transitive. Okay. Now the best example is, suppose I am taking 1 1, 2 2, 3 3 and 4 4. It's the best example if we have to utilize this note part. What is that? A comma A is there, obviously it is reflexive. Now while we are seeing symmetric, pair with two different number is not there. Means A comma B is not there. And its reverse, obviously, pair with two different numbers is also not there. So it would be symmetric also. And in case of transitive, A comma B means pair with two different number, and pair with two different number again with these two same. It is not like this there. Obviously, this is not also there. Hence, we can say that using this note, using this property, it is also transitive. So R is equal to 1 1 2 2 3 3 4 4 would be equivalence relation. So student, this is the part about relation. Now we will proceed towards function. Let us see. In class 11th we have studied about function, its parts, its types, graphs also there. Now here we will study, we have to actually, a function would be given to us and we have to recognize what type of the function it is. Now see, type of functions we will study here. Now see, we will break this concept into 4 parts. There are 4 types of functions we are going to study. It is, first one is 1 1 function. Second one is many one. Third one is onto, and fourth one is into. Now see, this we have done in class 11. This is the domain part. It is codomain part. Element of sets A we are writing here. Element of set B we are writing here. Suppose it is 1, 2, 3 and set is 4, 5, 6. And f is the function that is relating A to B. So it's the function f such that A to B. Okay. Now see, 1 1 itself name is indicating that image of one element is 1. 1 1 means image of one element is 1. It means image of single element would be single. So say image of 1 is 4, image of 2 is 5, image of 3 is 6. If a function is there like this, verifying this property, that image of one element is 1. Now if we have to define it, we can say that if each and every element of domain part, it is domain, is having a single image in codomain, then it is 1 1 function. एक एलिमेंट का एक इमेज रहेगा. Okay. Now many one. Now we come to many one. Many one name is again indicating that many to one means more than one elements will have a one image, single image. So if figure is like this, 1, 2, 3, 4. Now from the figure we are seeing that 1 and 2 having the image 5. Okay. 3 elements may also get single image. Although 3 is getting 6 and 4 is getting its image as 7. But 1 and 2 are having single image as 5. Okay. So now we can define it like, if more than one element of domain are having single image in codomain, then the function is known as many one function. Now we come to onto part. Always remember students, onto part we will verify from right side, codomain part. All elements of the codomain must be images of elements of domain. इसके अंदर कोई element that should not be left, छूटना नहीं चाहिए. This is the condition. All elements of codomain must be engaged with the elements of domain. If we have to define it, we can define a function in which all elements of codomain are the images of elements of its domain part, then the function is onto. Now we come to N2. Students, in N2 part, we are seeing that some element should be left out there in codomain. अगर codomain के अंदर elements कुछ छूटेंगे, then we can say that the function is N2. If we have to define it, we can define if some element, if a function f is like this, some elements of codomain are left without being images of element of domain, then the function is N2. So this is the graphical interpretation we can use if the question comes in board exam. Now there is one mathematical part. If we have to check, we have to find the kind of function. It is mathematical part. See, 4 1 1 and many one. Suppose the function let y equal to fx, this would be given obviously to you, and you need to find its kind, which kind of the function it is. Now its condition is, if fx equal to fy implies x is equal to y. We will proceed from fx equal to fy, and later on if we get x equal to y, then we can say that the fx is 1 1. Otherwise, if we don't get this, fx is onto. Sorry, many one. अगर x is equal to y आएगा then we say that the function is 1 1, and if we get x is not equal to y then the function would be manual. So it's a mathematical part that we can use also if we don't want to use that figure method. Now we proceed to the next part. So we take it in the note friends. First part of the note says a function y equal to fx equal to x, if fx equal to x is known as identity function. Identity function. Note number 2. It's about composite function. Now what is that composite function? It actually means function of function. It is function of function part. Now see, there are two functions, say f o, another function g. It means fog or gof type. Now see, now that we have been given fx equal to 2x plus 1 and say gx equal to x square, and we have to find the value of fog. So the simplest way is put the value of g in f. The simplest way. Now put the value of g in f. So you have to pick this, and now you have to put this in f. In f means in place of x only. So this you will pick, and you will have to put it in place of x. So it would be twice x square plus 1. Suppose you have to find gof, means you have to put the value of f in g. Now you have to pick f, you pick this, and you have to put in g. In g means in place of x. Square would be same. So it would be 2x plus 1 whole square. So this is the way you can find fog and gof mathematically. Now third one is the last kind of note. Third one is inverse function. All this will help us when we will finding invertible function. Now see. Third one is inverse function. Let y equal to fx be a function given, and we need to find what is f inverse x. What is f inverse x? Okay. It actually means that if a function is like this, a to b, function is a to b, okay. Elements of a are its domain part, elements of b are its range part. Now if we change it, if we make it from b to a, range part becomes domain and domain part becomes range, then the function would be f inverse. This is the graphical interpretation, but mathematically if we are doing, we have been given value of y in terms of x, and we simply need value of x in terms of y. That is what f inverse x is. Now we can understand it by taking an example. Say fx equal to 2x plus 3. Let fx as y. We have to find f inverse x. So y का value we have been given in terms of x. We have to find value of x in terms of y. X value would be y minus 3 upon 2. And remember, we normally write y equal to fx. So normally we must understand that x is equal to f inverse y. This is the basic concept. So as x is f inverse y, here you will replace x by f inverse y. So now you get f inverse y equal to y minus 3 upon 2. And then hold the equation, you can simply replace y by x, then you will get f inverse x is equal to x minus 3 upon 2. So by this manner you can find the inverse of the function. Now we come to the last concept of this chapter. That is, students, sometimes the question of 6 marks board exam, your CBSE board exam, that always comes. A function fx that will be given to you obviously. He says that check the function whether function is bijective or not. Sometimes he says check the function whether his function is 1 on 2 or not. And sometimes he says that check whether the function is invertible or not. Invertible or not. So students, first remember that all three have the same meaning. We will do the same solution. We will do the same solution for if any one of the three is asked. This one, this one, or this one. So what is that? Now we will learn. Invertible means a function whose inverse exists. And inverse we have just discussed in the previous point. ये function हमारा f है, that is from a to b, and if we take it from b to a, f inverse exists. Now say 1, 2, 3 and 4, 5, 6. Now see students, possibilities of a function that may be 1, 1 on 2, 1, 1 into, then many 1 on 2 and many 1 into. These are the all possibilities that may be. But we must remember that for invertible or any of these three, f inverse must exist. That is invertible. Now if we take 1, 1 into, 1, 1 into means some element should be left in the codomain part. It is like this. But when we think about f inverse, it would be like this. उस केस में डोमेन पार्ट में 7 छूट जाएगा और ये फंक्शन पॉसिबल नहीं होगा. We all know what is the condition of function. तो ये हमारा कट हो जाएगा. If the function is 1, 1 into, it cannot be inverse. इसका inverse नहीं हो सकता है. If we take many 1 on 2, it would be like this. It would be like this. And we will come back when it would be like this. So image of one element cannot have two images. It is against the law of function. So this also cancel out. Now many 1 into, it is again the same matter. If many 1 is there, obviously inverse is not possible, as image of one element cannot be more than 1. So this also cancel out. So the only way we get it is 1, 1 on 2. जिस रास्ते से हम जाएंगे उसी रास्ते से हमको लौट के आना है. उसी रास्ते से हमको लौट के आना है. That's why invertible, bijective or invertible all are the same meaning. To see what is the mathematical way of getting this valuable question correct. Now see, y equal to fx function that would be given to us, already written there. Firstly, we will find what is f inverse x. ये हमको निकालना है. This you need to find. Now, after getting this, you have to show if f o f inverse and f inverse o f both are identity function, both are equal to x. There are 3 or 4 methods to show this 1, 1 on 2 or invertible while you are showing 1, 1 then on 2 by figure method or by mathematical method. But this is the straightforward, easiest shortcut method. Although it is lengthy one. F O F inverse and F inverse to F both should be identity function, means value of both should be equal to x. If it is so there, then fx is invertible. So this is all in this part, partition function in this chapter. Thank you.